less than 10 seconds.
Hey, it's Cam Cronin here at the H.R. MacMillan Space Center for the Express, and today we're going to talk about a term that gets thrown around a lot, especially if you're, I don't know, 8 years old. You've probably been told you're moving at the speed of light. Which is funny because that's impossible. The speed of light is a really complex term, and it's something that astronomers use quite a bit because simply it's a way of shrinking distances that are out in space. When we think of fast things, there's lots of fast things out there. In fact, if we look at the very fast car, the fastest car there is the Bugatti right now. It goes about 431 kilometers an hour. The Blackbird SR-71, fantastic super jet, 3,500 kilometers an hour. The International Space Station goes 28,000 kilometers an hour around our world, and that means it only takes 90 minutes for the International Space Station to do one exact circle of our planet. Now, you might think that's pretty fast, but that has nothing on the speed of light. The speed of light is about 1 billion kilometers an hour. Now, what exactly does that mean? Well, let's say we wanted to go to the moon. Now, if you were traveling to the moon right now on a rocket ship, it would probably take you about 3 days to get there. Light traveling to the moon can make it there in about 1.3 seconds. So we know that light is fast, and we know it can travel huge distances in a very short period of time. But can it also do some pretty cool destructive things? Yes, it can. Now, light can be very, very powerful. I'm going to focus in on something a little bit more, cool, and that's laser light. Now, the idea for a laser is it's a concentrated energy from light. We're going to try a little experiment here, and I'm going to see if I can use light to actually blow something up. All right? So let me set up here. I'm going to put some safety goggles on. We'll dim the lights a little bit, and then we'll see if we can figure out if light can actually do something just by pointing light at something else. All right, so I'm going to put on my safety goggles, which is really important. I'm going to fire up my laser here, and we have a very special blue laser in this case, and it does carry with it a lot of ultraviolet light. And we have two balloons. We're going to see if we can actually blow these balloons out. Hey, and wow! Well, as you can see, our laser made short work of those balloons over there. But again, lasers like this, they're not really a toy. They're not something to play with. And we use this basically to illustrate the power of light. So yes, we can concentrate light so it can do cool, destructive things like blowing up balloons. But there's more to it than that. Using the same sort of laser technology, this is a new source of energy. It also has great military effects. So let's say you're out in the middle of the desert and you get dropped in by the military to, I don't know, overthrow some other country. You need a source of energy. Well, bringing fuel or gas or generators can be really, really expensive. But the military is looking at actually using laser energy. So bounce from a satellite up in space down to a laser collector, that team of men and women could be fine. They'd have a huge, unstoppable source of energy that was coming from space, beamed to an energy collector to be able to use in power. Light can really do some amazing things. Not only can it do some cool destructive things, again, it's something that's keeping us alive here on Earth. It can tell us a lot about the universe that we live in, and it can provide us, hopefully, with a cheap and reliable source of renewable power. So there you go. Lasers, light, speed, distance, we do it all. For the Express here at the H.R. MacMillan Space Center, I'm Cam Cronin, and remember, don't pipe these in anybody's eyes, because really, you'll go instantly blind.